Now let's have a look at what Haskell programs look like. The structure of a Haskell program is really just that it's a sequence of bindings that variable 1 is bound to the expression e1 up to variable n being bound to the expression en. Later on we're going to introduce other kinds of bindings, but for now we only consider these kinds of bindings, and for the most part that's enough. One thing that's really important to remember is that these are declarations. We declare variables v1 to vn to be the values of these expressions. They are not assignments. And if you try to treat them as assignments, you'll get an error message. You cannot do that in Haskell. Haskell is not an imperative language. That's the first thing to remember when you program in Haskell. What we're going to do now is we're going to look at expressions, these expressions, and see what expressions can look like. We'll look at expressions and their types. Before we do that, let's have a look at the types very briefly. In Haskell, types are grouped into type classes. So in Haskell, a type class is a family of types. This has nothing to do with object-oriented classes. A type class is a family of types. And let's have a look at some examples. One very important type class is the class show, and that's the class of types whose values can be displayed. And remember, a type class is a family of types, and so it contains types such as char and bool and int. So that's because characters can be shown on screen, booleans can be shown on screen, integers can be shown on screen. Another type class is a type class EQ. That's a class of types whose values can be compared with respect to equality. And it includes, among others, the type bool and the type int. Well, in fact, all types in the type class show. A third type class is the type class num. This is the class of number types. And it includes int and float and many more. Is this class related to the other type classes? Well, it's the case that if t is in the class num, we write if num t. So if t is in the class num, then we also have that t is in the class show and t is in the class EQ. So all number types can be displayed and can be compared with respect to equality. One last type class that I would like to mention is the class ord, which is the class of types whose values can be ordered. And it includes, among other things, the type int and the type char. There are many more, and all of these can be ordered with respect to an ordering relation which we denote by less than. So these are just some of the type classes that we have in Haskell. There are many more type classes. We've only scratched the surface. And in fact, you can define your own type class if you want. I'm not going to talk about this just now, but you can actually define your own type classes. So there's a lot going on here. In the next section, we'll look at some of the types that we find in Haskell and give examples of the type and present the type rules associated with them.